Here we go. And once again, the following Zoom session is to be recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. I'll bet you're tired of hearing this, aren't you? Yes, it'll be there every day. Okay, so today we're going to be covering section 14.2 eventually, but I have some requests for problems from 14.1, so I'm going to start with those, and then I'll take other questions if you have them. So can everybody see the thing that says today we will be covering section 14.2? Have I got that on correctly? Somebody?
Yes. Yes.
Yes. Okay, great. Thank you. All right. So let me look at something here. Let's see. It was problem 7. So this is problem 7 from yesterday, but again, you may have a particular different set of numbers, but this is the ones that were requested. So we have 5 factorial over 7 factorial. Well, the easiest way to reduce this is to consider this. 7 factorial could be written as 7 times 6 times 5 factorial, right? And then we have 5 factorial in the numerator. So these could be reduced down to 1 over 1, and I have 1 over 42. Any questions about that? And if the answer you want to give is 1 over 42, not some decimal approximation, okay? So we took out a 5 factorial from the numerator and the denominator, reduced it down to 1 over 1, and then we still had 42 in the denominator. Okay, let's see. Next up was number 9, and that looks like this. 6 factorial over 1 factorial times the quantity 6 minus 1 factorial. So that's 6 factorial over 1 factorial times 6 minus 1 would be 5 factorial. So now I'm going to write the numerator as 6 times 5 factorial. 1 factorial is just 1, so this is 1 times 5 factorial. The 5 factorial in the numerator and the 5 factorial in the denominator reduce down to 1 over 1, and I'm left with 6 over 1, or just 6. Let's see, so that was number 9 on somebody's WebAssign assignment. Any questions about that? All right, let's take a look at number 11. And this particular one is 6 factorial times 9 minus 6 factorial over 5 factorial times 8 factorial. So in the numerator, we've got 6 factorial times 9 minus 6 would be 3 factorial. And in the denominator, we've got 5 factorial times 8 factorial. All right. So let's see here. We could take the numerator and write, let's see, how do I want to do this? I think I'm going to take the 6 factorial and the 8 factorial. So I'm going to take this and make it 6 factorial, and then 8 times 7 times 6 factorial. And then here I'm going to take 3 factorial, and this is going to be 5 times 4 times 3 factorial. So again, let me kind of highlight what I'm doing there. I took this combination and turned it into that. So that way I can reduce out the 6 factorial over 6 factorial. I took this combination which is this, and created the situation where I could reduce out the 3 factorial, making it 1 over 1. So now, what have I got? In the numerator, I've got 1. In the denominator, I've got 5 times 4 times 8 times 7. Well, let's see. 5 times 4 times 8 times 7 is 1,120. Any questions about this particular problem? Now, I could have done this a different way. I'm going to do it again just to show you that, yeah, this isn't the only way I could have done it. So let me rewrite this. 6 factorial, 9 minus 6 factorial. And the reason I'm doing this is if you're sitting there going, well, that's not the way I did it. Is my way wrong? Not necessarily. Okay. So this becomes 6 factorial times 3 factorial, 5 factorial, 8 factorial. Now, in the previous example, I took the 6 factorial and the 8 factorial, reduced those. I took the 5 factorial and the 3 factorial and reduced those. Let's do it a different way this time. Let's take these and reduce them, and then those and reduce them, okay? So, dealing with this, I'm going to take 6 factorial and write it as 6 times 5 factorial over 5 factorial. I'm going to take 3 factorial over 8 factorial and write it as 3 factorial over 8 times 7 times 6 times 5 times 4 times 3 factorial. Can you see that doing it this way, I'm going to have more numbers to deal with? That's why I chose the other route, but this still works. So now those would reduce down. Those would reduce down. The 6 and the 6 reduce down, and I've got 1 over 8 times 7 times 5 times 4. Let's see, is that what I had there? Yep, 8 times 7 times 5 times 4. So I'm still going to get 1 over whatever that answer was. Let's see here. 1,120. So there you have it. Any questions about that particular problem? Okay, now we're going to look at another example. I believe it's the same question, just somebody else's different numbers. And it looks like this. 7 factorial times 10 minus 7 factorial over 6 factorial times 9 factorial. So I believe this is probably another version of problem 11. Maybe not, but anyway. So this is 7 factorial over 10 minus 7 would be 3 factorial. And then 6 factorial times 9 factorial. So again, as we saw from the last two examples, I can do the 7 factorial and the 6 factorial, or the 7 factorial and the 9 factorial. Either way, it's going to get there. Tell you what, I'll just do it straight up and down this time. So now I'm going to take 7 factorial and write it as 7 times 6 factorial over 6 factorial. So that way I'll be able to reduce out the 6 factorial. And I'm going to take 3 factorial on top. 9 factorial is going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial on the bottom. Okay. So now I can reduce out the 6 factorial on top and bottom, the 3 factorial on top and bottom. Keep in mind, they're not canceling, they're reducing, so there's still an implied or an actual 1 there in the place of it. Well, now I can take the 7 on top and the 7 on the bottom and reduce those down. And I've got 1 over 9 times 8 times 6 times 5 times 4, which is 1 over, calculator time, 9 times 8 times 6 times 5 times 4, and I get 8,640. And again, I did it kind of the longer way, but if I'd done it the other way, I would have gotten the same answer. All right, those were the problems that were requested ahead of time. Do you have any other questions you'd like to look at before we go on to the next section?
Number 12.
Number 12, all right. Can you just tell me what it is?
10 factorial over 8 factorial, parentheses 10 minus 8, close parentheses, factorial.
So like that?
Yeah.
Okay. So the first thing I would do is 10 minus 8 is 2 factorial. Okay. So I think I'd try to knock out that 8 factorial since that's a fairly large one. So on top, I'm going to have 10 times 9 times 8 factorial. In the denominator, I'm going to have 8 factorial times 2 times 1. I went ahead and took the 2 factorial and multiplied it out. So my 8 factorials will reduce out. The 10 on top and the 2 on the bottom reduce to 5 over 1. So now I've got 5 times 9 times 1 over 1 times 1 times 1, which is 45. All right with that?
Yeah, thank you.
You're welcome. Any other questions from 14.1? All righty, then we'll go on to section 14.2. And today's topic, we're going to talk about arithmetic sequences. Okay, so arithmetic sequences. Now, in my Math 50 class, when we were back in the normal classroom, I used to assign every other odd problem. Well, let's see how that would work. Let's say I just listed the odd problem starting with 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, etc., etc. Okay, so every other odd, that means that we would get rid of those kinds of problems, right? So we end up with something like 1, 5, 9, 13, 17, 21. Let's see, what would the next one be? 21, it'd be what, 25, etc. Okay, so you okay with what I'm doing so far? I'll take that as a yes. All right, well, let's look at something here. How do I get from 1 to 5? I would add 4. How would I get from 5 to 9? I would add 4. From 9 to 13, add 4, add 4, add 4, add 4. So in fact, let's see, 25 plus 4 would be 29. So the next number would be 29, all right? So the difference between these two numbers is 4. The difference between those two numbers is 4. The difference between those two numbers is 4. So we say that this sequence has a common difference of 4. All right. And in terms of our formula, we're going to say that D equals 4. So this arithmetic, as in arithmetic, sequence has a common difference of 4 between each consecutive term. Any questions about that? Okay, now let's go back here. We're going to call the first term in this sequence A sub 1. The subscript of 1 meaning it's the first, or the first term in the sequence. So the 5 would be A sub 2, then A sub 3, A sub 4, A sub 5, A sub 6, etc. Okay, so if we were to find the 14th term in the sequence, it would be A sub 14, whatever that is. Okay, any questions about that? All right. So let's see here. Could we describe this first term as a sub 1? Yes, we could. What about the next term? Isn't this a sub 1 plus 4? Okay, a sub 1 is that first term, the 1. So the next term would be the beginning term plus 4. You all right with that? Any questions? The next term would be a sub 1 plus, 2 times 4, because we added 4 and then we added 4. The next term would be a sub 1 plus 3 times 4, because we started with the first one, we added 4 once, twice, 3 times. This term would be a sub 1 plus 4 times 4. This term would be a sub 1 plus 5 times 4. Any questions? All right. In fact, let's go back here. And I could actually write this as 1 times 4. Okay. I don't really need the 1, but so, Is everybody still with me? Are you following what I'm doing? Okay, hopefully so. Let's say I want to find a certain term, okay? That general term would be a sub n, okay? Let's get more specific for a minute. Let's see, 1, 2, 3, 4, 5, 6. We'll go back to that. Let's find a sub 6. Now, I already know it's 21, but I'm going to find it using a formula. That would be the first term plus what? 1, 2, 3, 4, 5 times the common difference, right? So a sub 6 would be a sub 1 plus 5 times the common difference. So a sub 6 would be 1 plus 5 times 4, which is 21, okay? Now you might be saying, well, you already knew what it was. Why are we doing this? Because what if I wanted to find the 10th term or the 50th term or the 100th term, but I didn't want to go and figure them all out one at a time? But we're not quite there yet. This number was the common difference, right? The 4. Well, let's go back and let's call this a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. Okay? This number was the 1 plus 1 times 4. This number was the 1 plus 2 times 4. This number was the 1 plus 3 times 4. Do you see that this number here, the number I'm multiplying by 4, is 1 less than the subscript? Now, here we go with our leap of faith. So our general term would be a sub n equals a sub 1 plus n minus 1 times d. Now, that is a general formula for an arithmetic sequence. So what does that mean? A sub 1 is the first term. N is the subscript of the term you're trying to find. D is the established common difference, which we found by taking a term minus the previous term, a term minus the previous term, a term minus the previous term. Let's say I want to find the 20th term, okay? So a sub 20 would be 1, because that's the first term, plus 20 minus 1 times d, which in this case was 4. So 1 plus 19 times 4, 1 plus, what is that, 40, 76, 77. So if I went 1, 5, 9, 13, 17, 21, and I kept going, the 20th term would be 77. And I suppose I could prove it to you by writing them out one at a time, but unless you ask me, I'm not going to. You'll just take my word for it. Anybody want me to write out the first 20 terms? Willing to do it? Nope. Okay. So this formula is a formula that we will be using for arithmetic sequences. This is a formula that if we were in class, I would provide that on the test. So feel free to write that down and have that on a note card for your upcoming test. Okay. Now, we're going to take that formula and apply it in several situations here. So again, we've got this formula. A sub n equals a sub 1 plus n minus 1 times d, where n is the subscript of the term we're trying to find, and d is the common difference in the arithmetic sequence. Okay. Here's a problem. It says, write the first 5 terms of an arithmetic sequence with the given properties, which I will describe in a minute, and find the specified term. All right, this is what it says. It says the first term is 3. The common difference is 2, and then we are to find the 10th term. All right. Again, it said write the first 5 terms and then find the specified term. So we want a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and then a sub 10. Okay? So a sub 1 was given as 3. The common difference is 2. So that means as we go up the arithmetic sequence, we're going to keep increasing it by 2. So 3, 5, 7, 9, 11. Now, you could sit there and on a piece of paper go 13, 15, 17, 19, etc. But what if it said, what is the 112th term? You wouldn't want to do that. So here, the first 5 terms I can easily find just by adding the common difference. But a sub 10, we're going to use this formula to find it, okay, with the information that's given. So a sub 10 equals a sub 1, which is 3, plus n minus 1. In this case, n is 10. So 10 minus 1 times the common difference, which is 2. Are there any questions as to where I got those numbers before I finish this? Okay, so a sub 10 equals 3 plus 10 minus 1 is 9 times 2, which is 3 plus 18, which is 21. So a sub 10 is 21. Any questions about that? And again, you're probably thinking, oh, it would have been faster to just go 11, 13, 15, 17. But again, I could ask you a sub whatever, and you wouldn't want to sit there and have to do it one at a time. So you want to be able to use this formula. All right. Let's see here. Let's take a look at another example. This says, the first 3 terms of an arithmetic sequence are shown below. Find the specified term. All right. And they're saying 1, 4, and 7. And then they want us to find the 30th term. Okay. So we know that a sub 1 is 1, a sub 2 is 4, a sub 3 is 7. We want to find a sub 30. So using this formula, a sub n equals a sub 1 plus n minus 1 times d. So in order to find a sub 30, We need to know the first term, and we do know that. We need to know what n is. For that problem, n is going to be 30. And we need to find the common difference. All right, now, I said earlier to find the common difference, take any term in the sequence and subtract the previous term. What's 4 minus 1?
3.
What's 7 minus 4?
3.
Okay, so we could say that D is 3. Okay, so now we know A sub 1, we know D, and we know N. So A sub 30 is 1 plus 30 minus 1 times 3. A sub 30 is 1 plus 30 minus 1 times 3. Any question where I got that information? All right, so this is 1 plus 29 times 3. 1 plus, let's see, 60, 87. So that would be 88. So if I were to write out all 30 terms, the 30th term, let's see, would be 88. Any questions there? Okay. Let me see here. All right. My computer dinged and I thought maybe one of you had a message. Just a thing. So I know that there is like a sidebar where people can send me messages, but I don't typically look at that during this. So if somebody sends me a message, if somebody else sees it, say, hey, check your messages there. If you don't feel comfortable just asking it out loud. All right. We okay with this example? Let's take a look at another one. This says, write the first 5 terms of an arithmetic sequence with the following properties. The first term is 5, and the 5th term is 29. Now, why did I write all that? It says find the first 5 terms. So I want to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. They gave me a sub 1, they gave me a sub 5. So I need to find the 3 middle terms. Well, let's see. I know that a sub n equals a sub 1 plus n minus 1 times d. Well, I know that a sub n is 29, and I know that a sub 1 is 5, and I know that n would be 5, but I don't know what the common difference is, and I can't easily do that because I can't take a term minus the previous term because I don't have that yet. So let's see what we've got here. We could say that a sub 5 equals a sub 1, which is 5, plus n minus 1, which is 5 minus 1, times d. So filling in what I do know, a sub n equals a sub 1 plus n minus 1 times d, I get a sub 5 equals d plus 5 minus 1 times d. All right, any question how I got that?
Yeah, where'd you get the 5 from?
The first one or the second one?
Sorry,
This one?
not, yes, the
This
first one.
Okay, the
No,
first
no, no,
one.
the first
The
one.
first one is a sub n, a sub 1, excuse me, which was given.
Oh, okay, okay. Because
And then the
A1,
second
okay.
one is this, okay? All right. I'm
Perfect.
going to
Sorry about that.
simplify that just a little bit and say a sub 5 equals 5 plus what? 4d. Okay? So I know that a sub 5 equals 5 plus 4d. Oh, but you know what else I know? I know that a sub 5 equals 29. Well, if a sub 5 equals 5 plus 4d and a sub 5 equals 29, can't we conclude that 5 plus 4d equals 29? You see how I got there? A sub 5 equals this, A sub 5 equals that, so this equals that. Now I've got an equation with just one variable. I'll subtract 5. 4D equals 24. I'll divide by 4, and D equals 6. Well, if D equals 6, now I can come back and say 5 plus 6 is 11, plus 6 is 17, plus 6 is 23, plus 6 is 29. My guess is you'd like to see another one of those, am I right?
Yes.
Or maybe you'd like to never see them again. Unfortunately, that's not an option. So let's take a look at another problem. It says find the first 5 terms with the following properties. The first term is -4, the sixth term is -39. So A sub 1 is -4. And A sub 6 is 39. And it says to find the first 5 terms. So I need to find 2, 3, 4, and 5. Okay? So I'm going to use the formula A sub n equals A sub 1 plus the quantity n minus 1 times D. All right. Well, I know that A sub 6 is A sub 1, which is -4, plus n, which is 6, minus 1 times D. I don't know D, but I know everything else there. Simplifying it further, I could say A sub 6 equals -4 plus 6 minus 1 is 5, so plus 5D. But I also know that A sub 6 equals 39. Well, if A sub 6 equals -4 plus 5D, and A sub 6 equals 39, -4 plus 5D equals 39. So we're doing basically the same thing we did on the previous problem. Solving for D, I'm going to add 4 to both sides. 5D equals, is that 43? I don't like where this is going. So hang on, let's see. Okay, oh, you know what I did wrong? Looking down at the book, one problem has 4 and 39, and the next problem has -4 and -39. And this one, I took the -4 and the 39 and put them together. So I can fix this quite easily. Don't panic. My apologies. It should have been -39, okay? So I don't have to change anything else because everything up to that point was okay, all right? So I just wrote the wrong number down here. Are we okay? Gonna have to be more careful looking at my problems. So now I know -4 plus 5D equals -39. The reason I panicked is because I was getting a fraction and I thought, I'm pretty sure this problem shouldn't have that. So now I'm gonna add 4. 5D equals -35, divide by 5, and D equals -7. Okay. That should be a little better. -4 plus -7 is -11. -11 plus -7 is -18. -18 plus -7 is -25. -25 plus -7 is -32. -32 plus -7 is -39. Okay. So again, I had written down the problem. I think I did that yesterday too, wrote down the wrong numbers off the problems. This should be negative. Are you okay with that?
Yes.
All right. We're going to take a look at another problem. This says insert the given number of arithmetic means between the numbers. So an arithmetic mean is a middle number from which the two ends are equally distanced. I don't know if that's a word. So let's say I had like 5 and 9. The arithmetic mean would be 7, because 7 is halfway between 5 and 9, okay? But what if I had 5 and 11 and I wanted 2 arithmetic means? So I want 2 numbers in here that were, again, all 4 numbers are equally distanced. This would be a 7 and a 9, because this is 2 apart, 2 apart, 2 apart. Well, these are fairly simple examples. But what if things are a little bit more complicated? So let's take a look at how this works. Okay. So this says, insert the given number of arithmetic means between the numbers. It says, find 2 arithmetic means between 2 and 11. Between 2 and 11. So that means I've got 2, then I've got some number, then I've got some number, and then I've got 11, okay? And again, we could sit there and play with it and eventually figure it out, but what if things were bigger and not as friendly? So we need a process to do that. Okay. So we know that our beginning term is 2. We know that we want 2 arithmetic means between 2 and 11. That means that 2 is the first term of the sequence, and 11 would be the 4th term. Now again, where did I come up with 11 is a sub 4? Because they wanted 2 arithmetic means in between the 2 numbers, okay? So I want 2 of them in between there. All right? So again, we're going to use a sub n equals a sub 1 plus n minus 1 times d. You can start to see this is pretty much just like the last 2 problems. The only difference is we needed to know how many numbers we needed to find in the middle. So a sub 4 is a sub 1, which is 2, plus n minus 1, which is 4 minus 1 times d. Any questions where I got the 2 or the 4? Simplifying, a sub 4 is 2 plus, let's see, 4 minus 1 is 3d. But we also know that a sub 4 is 11. So that means 2 plus 3d equals 11. Subtract 2 from both sides. 3d equals 9. Divide by 3, and d equals 3. Well, if the common difference is 3, then 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. So let's see here. Basically, let's see, the 2 arithmetic means. So the answer would be that 5 and 8 are the 2 arithmetic means. Any questions on that particular problem?
No.
Okay, let's take a look at another one. We're to find 4 arithmetic means between 10 and 20. So between 10 and 20. So a sub 1 is 10, but we want 4, yeah, 4 arithmetic means. So a sub 2, a sub 3, a sub 4, a sub 5, and then a sub 6 would be 20. Again, how do I know? Because I want 4 in the middle. 4 arithmetic means. Okay. So again, using a sub n equals a sub 1 plus n minus 1 times d. A sub 6 would be a sub 1, which is 10, plus 6 minus 1 times d, which is 10 plus 5d. But we also know that a sub 6 is 20, therefore 10 plus 5d equals 20. Subtract 10 from both sides. 5d equals 10. Divide by 5d equals 2. So 10 plus 2 is 12, plus 2 is 14, plus 2 is 16, plus 2 is 18, plus 2 is 20. So the four arithmetic means would be 12, 14, 16, and 18. All right. Lest you think they're all real nice, I'll give you one that's a little not nicer. That's a new word of mine, not nicer. Okay. This says find 3 arithmetic means between 20 and 30. So 20 and 30. So a sub 1 is 20. And we want 3 in the middle. So a sub 5 is 30. Okay? Because we're looking for 3 arithmetic means. So once again, a sub n equals a sub 1 plus n minus 1 times d. Now, I said you could have this during the test, but by the time you're done with the assignment, you'd probably have this thing memorized anyway, hopefully. So that means a sub, whoops, not a sub 30. Pay attention here. A sub 5 equals a sub 1 plus 5 minus 1 times d, which is 20 plus 4d. Okay, so a sub 5 is 20 plus 4d, but a sub 5 is also 30, which means 20 plus 4d equals 30. Subtract 20, 4d equals 10, divide by 4d equals 5 halves. Now, earlier I panicked when I got a fraction answer because I wasn't supposed to get one. Here I am supposed to get one. So now let's see here. And I suppose we could give our answer as mixed numbers or fractions. I'm going to do it with fractions. So a sub 2 would be 20 plus 5 halves. Okay? Well, let's see. 20 plus 5 halves would be 40 halves plus 5 halves, which is 45 halves. Okay, 20 over 1, multiply by 2 over 2, you get 40 over 2. Are we okay with that? Any questions there? All right, so a sub 3 is going to be 45 halves plus 5 halves, which is 50 halves. Well, that just comes out to a nice 25. 25 plus 5 halves, which is 50 halves plus 5 halves would be 55 halves. 55 halves plus 5 halves is 60 halves, which is 30. Good, verification. So my 3 arithmetic means would be 45 halves, 25, and 55 halves. Now, in WebAssign, they might want the fraction, they might take the mixed number, so you'll just have to experiment and see. You know, you could put in the, I'm pretty sure they would take the fraction. Whether they'll take the mixed number like 45 halves would be what, 22.5 or 22.5? I don't know for sure whether it will accept it. It should, but maybe, maybe not. All right. Let's see here. Let's do one more. We want to find one arithmetic mean between negative 6.5 and 8.5. So negative 6.5 and 8.5. One arithmetic mean. So the first term is negative 6.5, the third term is 8.5. Okay, so we want to find the middle term. Once again, a sub n equals a sub 1 plus n minus 1 times d. A sub 3 equals negative 6.5 plus 3 minus 1 times d. A sub 3 equals negative 6.5 plus 2d. But a sub 3 also equals 8.5. So negative 6.5 plus 2d equals 8.5. Again, can you see I'm doing the same thing over and over and over? We're going to add 6.5 to both sides. 2d equals 15. Divide by 2, d equals 7.5. Now, I could have left it as 15 halves or as 7.5, but because the others were in decimals, I went with decimals. So that's the common difference. Negative 6.5 plus 7.5 would be 1. 1 plus 7.5 would be 8.5. So the one arithmetic mean would be 1. All right. Any questions about anything before we quit for the day? All right. I will be back during my office hour at 1:15. If you've got any questions then, come visit me. Otherwise, have a great day. And I'm going to stop the recording.